So a shape can be folded to see if it has a line of symmetry. And then we say that a shape has a line of symmetry when the folded part sits perfectly on top with all edges matching. So for example, in this diagram that is shown here, this could be a star. It's kind of a star, but not really a star. So we have this shape 1, we have this shape 2, then this shape 3, and then this is the 4th one. So if you're to look at them carefully, folding the shape at different points, you need to know that only the 4th shape here is a line of symmetry. So if you are to fold this shape on this line, this side, if it's to overlap onto this side, you will notice that the edges of this shape will perfectly sit on top of each other. Thus it is a line of symmetry. And then in this case, we say that this shape is one line of symmetry because it can only be folded once so that its edges can perfectly match. Okay. So in regular polygons, you need to note that the number of lines of a symmetry in a regular polygon is equal to the number of sides. So for example, a square is a regular polygon. It has 4 sides. And then, so we say that it is 4 lines of symmetry. So like we said here, we say that the number of lines of symmetry is equal to the number of sides of the polygon. So if a square has 4 sides, it has 4 lines of symmetry. And then a regular pentagon is 5 sides. Thus we say it is 5 lines of symmetry. So this can be shown diagrammatically here as shown on the screen. And then now we are going to look at rotational symmetry. So a shape has rotational symmetry when it can be rotated and it looks the same. So when we say rotated, we are rotating in a 360 degrees, so like a complete revolution. So we rotated 360 degrees, and if it still looks the same, then we say it is a rotational symmetry. So the order of rotational symmetry of a shape is the number of times it can be rotated around a full circle, which is 360 degrees, and it still looks the same, right? So here we have a diagram representing 2 different kinds of shapes. This is a star and this is a triangle. So firstly, we rotated the star. So you need to take note of this mark here. It's our reference point. It's our reference mark. So firstly, the shape is standing like this, right, on one. And then when we rotate it, note that this mark is here. The star still looks the same. There's no difference. And then when you rotate it again, note that the mark is now here. There is no difference again in the way the shape looks. And then when we rotate it again for the 4th time, notice that the shape looks the same again. And then for the 5th time, when the mark is here, the shape still looks the same. So in this case, we say that the star has a rotational symmetry of order 5, because in a complete circle or in a complete revolution, the star can look the same 5 times. So this is the 1st time, the 2nd time, the 3rd time, the 4th time, the 5th time. So we say that it is a rotational symmetry of order 5. And then now we come to the right angled triangle here. So in the first one, know that the mark is here, right? So this is when it's standing like this in the first set. And then when we rotate it, note that that mark is here, but it doesn't look the same like in position 1. And when we rotate it again, it doesn't look like the triangle in position 1. And when we rotate it again, it doesn't look like the triangle in position 1. So this then says that if the triangle is rotated a full 360 degrees, it never looks the same except when it arrives back at its original starting point. So we say that it has one order of rotational symmetry. So this right angle triangle here has a rotational symmetry of order 1. And you need to know that the minimum order of rotational symmetry of a shape is 1. That is the minimum that any shape can have. That is when, when you rotate something, it will always come back to its original position. So even if, you rotate it, it doesn't have many rotational symmetry orders. It will always have that one order of rotational symmetry. So now we're going to look at rotational symmetry in regular polygons. So the order of rotational symmetry of a regular polygon is equal to the number of sides of that polygon. So there, like we looked before, there are 6 special quadrilaterals with different symmetrical properties. So for example, a square is a regular polygon. It has 4 sides, so it has rotational symmetry of order 4, right? And then a rectangle is not a regular polygon. So a rectangle has 2 lines of symmetry that are shown in purple, and then it has rotational symmetry of order 2. So you might as well want to be trying out this, like maybe you might cut out your own triangle and then you'll be rotating it so that you see how many rotational symmetry orders it has. And then a parallelogram, it has no lines of symmetry, and then it has rotational symmetry of order 2. And then a rhombus has 2 lines of symmetry, which are shown in purple, and then it has a rotational symmetry of order 2. A trapezium, so it depends. With trapeziums, it depends. So some trapeziums have 1 line of symmetry, and these are called isosceles trapeziums, as they have 2 sides which are equal in length, just like in an isosceles triangle. So for example, this one would be the isosceles trapezium because it is this side equal to this side. So this is the trapezium. This is the isosceles trapezium, which has 1 line of symmetry. However, this trapezium, it does not have any line of symmetry. So it's dependable on which trapezium you're talking about. So you also need to note that a trapezium has rotational symmetry of order 1, whether it is an isosceles trapezium or just an ordinary trapezium. And then the last shape that we're going to look at is the kite. So a kite has 1 line of symmetry, which is shown in purple, and then you need to know that it has rotational symmetry of order 1. So I hope you found this video helpful. Thank you for watching my video. See you in the next